Hey guys, in the last lesson we talked a bit about namespaces and how we can use them to organize our code a bit, but we didn't actually use a namespace. So in this part we're going to start out by using a namespace, and we're going to use this namespace throughout our project so that we know that anything that we define is within our very own namespace. So if we have a class that we create that shares a name with something in a different namespace, say maybe inside the Unity engine or a third-party library that we use, it'll be easy to differentiate between our class and Unity's class, or our class and that third-party library's class, because we can qualify it. We can qualify it with a namespace. So we're going to do that really quickly here, and we're just going to type in the word namespace, just one word, namespace. And I'm going to call this text RPG. And we're going to do it just like we're defining a class or a method. We're going to have the curly braces here. Just namespace, text RPG, and then curly braces. And inside of that, we have our character. And now you have this other thing to think about in terms of scope. So we have text RPG dot character dot energy and then dot attack, however you want to see that, using dot notation. You can go through them in a sense, kind of like a directory or like a folder, to qualify which object you're looking for, which member of which object, and so on. So we're going to be using this throughout our project to organize our code a bit better for us. Now in this lesson we're going to talk about creating a couple of virtual methods that will then override in our classes that extend character, so our enemy classes for instance. We're going to have a couple of methods that can handle taking damage and also handle dying if we get below 0 health or 0 energy. So if this happens, maybe our enemy does something differently when it dies as opposed to when our player dies. Because I know when our player dies, it's probably game over, right? I mean, the game's over, you died, start over from the beginning. If the enemy dies, it's probably best if we somehow set it up so we can loot the body, so we can get the loot from the enemy and add that to our player's inventory. So a couple of different things have to happen depending on if it's an enemy character or a player character. So we'll also look into doing that. So what I want to do is I want to set it up so that I can define base functionality that all characters will have, and then make it easy to override that functionality and extend that functionality for our enemy and for our player. So to do that, I'm going to create a method. It's going to be a void method. It's going to be called take damage. And it's going to take a parameter that's an integer called amount. So it's just going to take an amount of damage that you are dealing to this character. And what this would do is it would probably take your energy level and it would subtract the amount from it, right? So take your current energy level and take the amount that we pass that and subtract it. So now we have our new energy level after we dealt damage to it. Then we could easily just check to see, if energy is less than or equal to 0, then you're dead. So you would just die and put a comment in there for now. You die if that happens. And that's fine. But we were talking about being able to override the functionality in our player or in our enemy class. So to do that, we have to define the method a bit differently. What I want to do is I want to call this a virtual void take damage. It's a virtual method. And that's going to say, I don't know what you're talking about because it can't be private, but that's fine. We'll change that here in a second. But what this means is this method is still a method. It still works like a method I can call take damage as you would expect. But the difference is any class, any object that inherits from this class has the ability, it has the right to override the functionality of this defined take damage with its very own defined take damage method. And the cool thing is you can still keep the same functionality. You can just tack on new functionality. So I'll show you how we'll do that. But first I want to make this a public. It can also be a protected. Remember how I talked about public and protected? That means that it can only be accessed within the thing inheriting character, but we want this to be accessed outside of the inheritance chain for character. So we're going to make sure we set it to public, so again it can be accessed outside of character. So a public virtual just means it can be overridden by using the override keyword. We're using the virtual keyword here to define that this may have an override. Check for that before you just call this. So the way it's going to work is when we set up a take damage in our enemy class or a player class, it's going to actually go here and it's going to say, okay, I want to make sure I don't have further down the line a take damage that has different functionality. Because if I do, I want to call that one from the latest inheritance, the latest derivative of character. So if it does have it, then it's going to use the override. Pretty cool. So we'll get into that here in just a second. I also want to set up another public virtual void. It's just going to be called die. A little dark sounding, but it's what it's going to do. It's going to die. So if energy is less than or equal to 0, we're going to call the die method. And notice how this is a virtual method, right? Which means it can be overridden from a class that inherits this class, but it can also just be used like a regular method because it's currently not being overridden. But when I do call this, it's going to say, this could be overridden. Let me make sure it's not. And if it is, we'll call the latest version, in a sense, the latest in the chain of inheritance. So when we die, what do? I don't know, I'm going to log out a message to the console that just says, game over. And we're not going to be using the console for our text-based RPG. We're going to have our own little like chat box-esque thing that we're going to add our logs to, add our messages to. We're going to have some buttons on screen to control what happens whenever we attack and open a chest, and we're going to have some movement buttons on the screen so we can move throughout the dungeon. It can be pretty cool. So that's all we need right now for this. Now what I want to do is I want to create an enemy. So we can define an enemy that will use this information however we would like. Back into Unity, I'm going to create a new C# script, and I'm going to call it enemy. Just like that. Open that up, reload solution, just to make sure we got everything talking to each other. Save character there. And now enemy. This is where it gets fun. And actually, I don't have everything talking to each other. I broke everything. Because this is not actually highlighted, saying that it understands that this exists in the solution. So I'll have to fix that here in a second. That's fine though. So I'm going to say I want to inherit from character. Now notice it's not telling me that it understands what character is. And the reason that is because character is defined in a specific namespace called text RPG. So I could do this by saying text RPG.character, and then it will understand it. Actually, it's not telling me that it understands it because it is not working. It's not actually rebuilt the solution correctly. I get so many issues with 2017 Visual Studio versus 2015 with Unity, at least, because I create these objects, I create the new script files, and they don't, the solution, something's broken with the solution. Alright, so after a bunch of ridiculous debugging and trying to figure out why my Visual Studio wasn't reloading my solution properly, I've got it fixed for us. What we can see now is that textrpg.character is actually working. To show you that it wasn't working before, I get rid of that. It says I don't know what character is because character is within a namespace that we're not actually qualifying character with. We're not using it to say character is a part of this namespace, like if we were to do textrpg.character, just like that. So we could also do it this way, where we say using text RPG. And now it knows, okay, we're using that namespace, character is a part of that namespace, works out fine for me. And that works out pretty cool. Or you could also just include enemy in the same namespace by saying namespace text RPG, just like we did for the character, just like that. Either way you want to do it, I'm going to do it this way for now. All right, and now enemy is inheriting from character. So we talked about this a bunch at the beginning, but what does it actually mean for us? If I have a start method like I normally would here, what I want to do is in start, when this object is initialized, I want to set up the values for this character. Right? So say we have an enemy, I could say that the energy for this enemy is 20, and the attack for this enemy is 5. Now notice I have not initialized these variables. They're not defined in enemy. They're defined in character, but I still have access to them directly. And that means that enemy has access to everything inside of character that it has exposed to it, depending on the scope, which is pretty cool. So let's get rid of that for now. And if I were to take and say, since we want to do these methods here, I have public virtual void take damage and public virtual void die. So let's say that this would just be character has died whenever a character dies, just a character in general. But then whenever an enemy dies, I want to say something differently. So I'm going to have a public override. That's the new keyword here. We're not using virtual, we're overriding a virtual method. So I'm going to say override void once again, and it's giving me options. It says, okay, I know what you're looking for. You're looking for an override. These are the methods that you can override from character, because you are extending from character, so you can have access to these methods. And I'm going to say it's take damage, and this is what it does for me. It fills out the rest for me. It includes the arguments, and it also has something that says base.takedamage amount. So what's going on here is this is going to call from the base class the parent class of character, if you will. Enemy is a character, character is this, and it's going to call the method here that is take damage, which means it's going to do whatever we have defined here. And then I can also tack on some more stuff. So it's going to take the damage like that normally. Then I could say this also happens, but only on enemy, not other characters. So that means that I have tacked this on to also happen after the base class take damage happens, which is pretty cool. And then I can also do this for my public override void, and it's going to be called die, which doesn't take a parameter. And I'm going to call the base die method. So it's also going to call this method right here, character has died. And then I can tack on my own information as well. Say debug.log, character died was enemy. That's cool, right? So it's also going to have that. It's going to say character has died and then character died was enemy. I can also get rid of base.die. Maybe it doesn't need to do what the base die does. It can do its own unique thing. And now the base class die won't be called. It only happens, what I define in here only happens, which is pretty cool. So die would do something differently than what character does when it dies. I just wanted to throw another point in here really quickly that the reason this is so cool, and we get into this later on when we talk about a bit more about polymorphism, but the reason this is so cool is because I can still just call the character's die method or the character's take damage method. I don't have to call it on the enemy. I don't have to call it on anything that inherits character. I just call it on character if I want to. I can just look for an object of type character and call die on it, and it will actually call the latest version on my enemy or on my raccoon that we're going to make, or my walrus or my player, whatever it may be. You don't have to specify the derived class. You just have to call it on the base class, which is kind of the foundation of polymorphism that we'll talk a bit more about later on in the course. So now we could also take player and say player is its own thing that does its own thing when it dies. Pretty cool. And we'll get into using this a bit later on. I'm just showing you how we can override some methods that exist in the base class, in the parent class of our child classes. Now let's say that we wanted to create a couple of unique enemies. So I could sit in here and define that the energy level's 20, the attack level's 10 for enemy, whatever enemy may be, and then the defense level's 7, it has 20 gold on it and these items and blah blah blah. But that just means that I have a generic enemy class with generic enemy stats, and I don't have any unique enemies. What I want to do is create enemies that are unique. So I want to have a raccoon and a walrus, the most feared creatures in all of the world, and I want them to have stats that are different from each other, but they're still going to be based on the character class because they're based on the enemy class, which is pretty cool. We're going to have not just one layer of inheritance here, but we're going to have 2 layers of inheritance. We're going to have a raccoon that inherits from enemy, enemy then inherits from character, character inherits from mono behavior, and so on. It's pretty cool. So we still get the functionality of all the things in the chain that are exposed to each other. And the latest derived class is the one that you can override and have it be the thing that gets called. So if in my raccoon I have a take damage that overrides, it'll override this override, which overrides the base virtual. Pretty cool. So I'm going to go back into Unity. I'm going to right click, create C# script, and I'm going to create a raccoon. And now I bet I'm going to have to do all that stuff again to get this to understand. I'm going to save the scene as a test scene. And I want to see if I can open this up and it just work, and it does not. It's not included in my scripts. So I want to go over here, right click. I'm going to go to add. I'm going to add existing item. Maybe it'll work very easily for me this time. And just add. There we go. It worked. Pretty cool. So now I want to take a raccoon, and it's not going to inherit from on a behavior directly. It's going to inherit from enemy, which inherits from character, which inherits from mono behavior. And again, we're getting an error here that says, I don't know what enemy is. You've not given me any context. So again, I can define the namespace however I'd like, but I'm going to add this to our namespace of text RPG. And again, the same thing here. Boom, 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 boom. And now raccoon is a part of the text RPG. And raccoon inherits from enemy, which inherits from character, which inherits from mono behavior, and so on. So now raccoon has this, which has this. Pretty cool. So what I want to do now is in my start method here, this is where I'm going to define what my raccoon is, what kind of stats my raccoon has. So if I take my energy level and I say it's for the raccoon it's 10, and my attack level for the raccoon is 5, and my defense level for the raccoon is 3, or whatever it may be. Oop. And I have 20 gold, and I have a position of something. I'm not going to define the position directly because we're going to randomly generate a dungeon and then randomly place our enemies throughout this dungeon, which sounds pretty cool, right? It sounds kind of complex though, but don't worry about it. I'm going to make it very simple for us to cover, and you're going to like it, I bet. So I'm going to do gold is equal to 20, and then I'm going to do, we're going to have items. Right? We want to be able to have items unique to our enemies. They don't do anything. They're just, again, something to collect. So I'm going to say we have an inventory list here. I'm going to say inventory is equal to, now it's a list of items. So I could do inventory.add. I could say add item of, hey, it's an item, right? But what's happening here is, if I go back to my character, I have inventory, and it has an auto-implementing property. And that's cool, but it's not actually initializing the list. I'm not creating a list from this. If you create the standard field like you normally would, you would just do equals new list string, just like that, right? Very familiar. You know how to do that. So let's do something similar with our get and our set. And we'll say it's equal to new list, string, boom, boom, boom. Oh no, I don't have the new C# enabled. Is that possible to do? I forgot that I have a new version of Unity because I have a new hard drive and I haven't changed all these things. Okay, so to enable the C# 6 functionality, we're going to go into our player settings, which is edit. I had to find it myself here. You're going to go to project settings and then go over to player. And then you're going to go down to your PC, go to other settings. And you're going to go down to configuration, scripting runtime version, and I want to set it to experimental.NET 4.6. Not that important really for this. I just think it's really, honestly, it's been years, and it's finally time that we get an updated version of .NET and C#. So we're going to make use of that for this. I'm going to turn that on, and I'm going to restart. And since I am working on a new hard drive, I do not have the latest framework installed, so I'm going to select download target package. And now that I have everything set up and installed, it was simple as downloading the 4.6 targeting pack, which is usually installed, I thought, when you got the new experimental version, but I guess not for mine. Maybe I unchecked the box accidentally. But I have it installed now, so now you can see that I have initializer for my auto-implementing property, which is just the same thing as it was like this, but with an auto-implementing property. Pretty cool. So now I don't have to implement, or I don't have to initialize this list before I can use it elsewhere, such as in Raccoon. So I'm going to have inventory.add, and I'm going to add that this guy can drop, he can drop a bandit mask. That's pretty cool, right? Which is all I guess I need for that. And he also has, what else do I need to define for this guy? Nothing. That's it for that. And I can also override the take damage and the die methods if a raccoon is different than a walrus, but I don't think it's going to be. I think they're going to be very similar in how they die and take damage. So now I'm going to wrap this video up, this lesson up, with just duplicating my raccoon here. I'm going to select it, hit Control D, And I'm going to call this a walrus, because those things are menacing. So I'm going to make this a walrus, which is going to have more energy. It's going to have less attack and more defense. Kind of a tanky enemy. Doesn't really matter, honestly. But it's going to be a tanky enemy, and it's going to drop a walrus. Not a wall. I think it's going to drop a walrus. It's going to drop a, I don't know, what's its, a tooth. It's going to drop a tooth. Okay, that's fine. And that's all we need for these enemies, really. We'll add a couple of things later on to the take damage and the die methods for both of the enemy and the player. But that's going to do it for this lesson. We'll continue our simple text RPG in the next lesson.